All right, David, go ahead and read for us this paragraph. Nice and loud.
The set of imaginary numbers is the set of all numbers written in the form of a plus b, where a and b are real numbers and b is not equal to 0. A pure imaginary number is a number of the form bi, where b is not equal to 0.
All right, let's go ahead and write this. So we're going to write the a value. Whatever you have as the a value, that's going to be the real. And this next part is called the imaginary. Dora, can you read number 1 for us, please?
Write the imaginary number I in the form a plus bi, what is the values of a and b?
Okay. Dora, can you make up a number for us, please? Any number? 7, and your b value. So if I'm going to write these, it's going to be 7 plus 3i. So if you make up some numbers, 7 plus 3i. Now, number 2. Justin, read for us, nice and loud.
Give an example of a pure imaginary number.
A pure imaginary number, that means just this goes away. So this number would have to be what class? 0, and you can make up a number. Someone make up a number. How about minus 5i? So negative 5i is an example of a pure imaginary number. It doesn't have the real. The real part is the a value, or the one in front. Okay? Read for us the next part. Jocelyn, read the bubble for us, please. Imaginary numbers. Thanks. Valerie, can you read number 3, please? No. Only one real or one imaginary. Number can't be both. Thank you, Valerie. Joe, can you read the next paragraph for us, please? The set.
The set of complex numbers is a set of all the numbers written in the form a plus bi, where a and b are real numbers. The term a is called the real part of the complex number, and the term bi is called the imaginary part of the complex number.
All right. Joe, can you read the directions for number 4, please?
Identify whether each number is a complex number and
Okay. So, I'm going to summarize the real and the imaginary. We're going to color code this so you can kind of see it. This whole column will be the reals, and then this whole column will be the imaginary. I'll do 2 examples, and then you guys will do the others. Now the form is an a plus bi. So the real is the letter a, and the imaginary is bi. The a's and the b's don't matter; they're just numbers. And you're putting the ones that have no letter i's here, and those that have a letter I on the right side. Watch this. I. Classes that represent the real or the imaginary? So I'm going to put the I over here. Class, there's no number here. So what number can I write? And what number is in front of the imaginary? a 1. So 0 plus 1i is in the form of a plus bi. Although they gave me just an I, and we just learned above, they call this a pure imaginary because there's no real. And the question is, determine or identify whether each number is complex. So is this one complex? It is, because it has the letter I in it. Okay, try this one over here. Class, where does the 3 go? Pink or yellow? In the pink or the real. Class, do you have anything for the imaginary?
No.
What number are you going to write there? What number? 0. So 3 is the same thing as 3 plus 0i. We don't have a number here, therefore is this complex? Not complex. Alright, so I want to make a correction here. A complex number actually is composed of both imaginary and complex. Sorry, I'd say that again. Complex is composed of both a real and an imaginary. So if it has a real, or if it has an imaginary, or if it has both, like in example D, then it is a complex. So is it a complex? The answer is yes for all of them. So that was my mistake. Let me summarize that again. If it has a real, like this example, if it has an imaginary, or if it has both, then it is going to be a complex. So all of these are examples of complex numbers. Okay? Let's go through and help us write the rest of these. Raphael? C, where does that number go? Pink or yellow?
B.
So therefore this is a real or imaginary. That is a real number. What is your imaginary?
0i.
0i, and it is a complex. Angel, here. Amy, D, what goes under the real? .2? But remember, 3.2 has what on it? And what does I represent? It represents the imaginary. So I'm going to write 3.2i over here. What do you think you're going to write over here for the real? Pi. The reason why you write pi over here, because pi is approximately what? 3.14. So in some ways you can think of it as this. 3.14 or pi plus this. So this is written in the form of the real plus the imaginary, and it is a complex.
I love math. You don't love math? What's wrong with you?